First human-level AGI, the first human-level artificial general intelligence, will be the last invention that humanity needs to make. And the reason for that is once you get a human-level AGI, you can teach this human-level AGI math and programming and AI theory and cognitive science and neuroscience. This human-level AGI can then reprogram itself, and it can modify its own mind, and it can make itself into a yet smarter machine. It can make 10,000 copies of itself, some of which are much more intelligent than the original. And once the first human-level AGI has created the second one, which is smarter than itself, well, that second one will be even better at AI programming and hardware design and cognitive science and so forth. And we'll be able to create the third human-level AGI, which by now will be well beyond human level. So you may see what some futurists have called a hard takeoff, where you see the intelligence increase literally day by day as the AI system rewrites its own mind and existence. I mean, if you have a million times human IQ and you can reconfigure elementary particles into new forms of matter at will, then supplying a few billion humans with, food and water and video games, virtual reality headsets and national parks and flying cars and whatnot, this would be trivial for these superhuman minds.
AI is one of the most important things humanity is working on.
Artificial intelligence.
Artificial intelligence.
Artificial intelligence. Artificial intelligence.
AI is
AI.
AI.
AI. AI.
AI.
AI.
AI.
You mentioned this to me yesterday. I really had kind of no idea what you were talking about, and then I looked up Ian Banks' neural lace. That's right. So it's this concept of wiring the brain. So it's either there could be a brain internet, and it could also mean that we can upload our thoughts to the cloud.
You would never forget anything. You wouldn't need to take photographs.
Yeah. I know, it's incredible. I mean, you would never forget anything. You would expand your ability to process information, to remember information, right?
And I think it actually would be quite an equalizer as well, because I think the delta between it would sort of even things out. I think.
You mean in humankind? There would be no education disadvantage. Everyone would be starting at the same level.
Yeah.
So there would be no meritocracy. No, there would be meritocracy.
There would be, but it would be the differences would be smaller.
Artificial intelligence. It is a renaissance. It is a golden age. We are now solving problems with machine learning and artificial intelligence that were, kind of in the realm of science fiction for the last several decades.
Essentially, it's the product of information processing. While life on the lower spectrum of intelligence can only use it to survive, the complexity of our brain allows us to do much more with the information. It enables us to understand patterns of the outside world, of reality. In ancient times, those patterns could only be observed individually or could be shared with the local community. In the course of time, we developed language and writing, which allowed us to record individual observations, look at other people's observations, and develop on them further. This process allowed humanity to act as a collective intelligence. Thousands of years of this continuous cycle of learning and accumulation of knowledge has led us to a point where we have enough understanding of intelligence itself that we can actually simulate intelligence, a human-made intelligence, an artificial intelligence. In the case of a computer, when you press the B on your keyboard, the letter B appears on your screen. Not because the computer understood that you pressed B, but because it has been programmed to configure the pixels on the screen so that they form a B. When it is playing you a movie, it is doing the same thing, just on an entirely different scale. When you ask your phone or PC to do something, electrical signals move at the speed of light through the billions of transistors inside the computer, performing computations on the input information and producing a response that was coded to that particular set of input information by some other human. So a computer does not create its own outputs. For a computer to be called intelligent, it will have to be independent. But how do we make computers operate independently of humans?
The concept of programmable matter really is a nanotechnology concept where we can create things atom by atom, and there are already paradigms that have been defined. If you can build things at that scale, you can build things that will reconfigure themselves. The idea of foglets goes back a couple decades, which are basically tiny little robots that connect to each other and their intelligence, and they can reconfigure themselves, kind of like transformers, but at a really microscopic level. So really a couch can reconfigure into a chair, into a bicycle, into a person, into an avatar representing someone else. You will then be able to actually transform yourself, project yourself into a space that's far away. That's the whole concept of an avatar. Just that will become sooner. I think within 10 years you'll be able to actually project yourself somewhere else without nanotechnology. But pretty realistically, it'll look like you and you'll feel like you're there. Once we have programmable matter at the nanotechnology level, you could reconfigure yourself into a completely different person. So you could look like you ordinarily do with your biological body, or you can look like someone else and reconfigure yourself. So it brings this sort of morphing ability, which is readily doable in virtual reality, to real reality. But that's probably a 2040s scenario. I would say within 10 years, you'll be able to project yourself as an avatar. And you could also there.
What if we could make a computer learn? To make it recognize patterns in the information. That's the idea behind machine learning, making the computer learn from data, and data is the information in the digitized form. Let's take a look at a simple example of how machine learning works in computers. A machine learning program is tasked to identify an animal as a cat by writing a code that tells the program to say cat when it sees a picture of a particular cat. The program is shown a lot of pictures of different animals, and each picture is labeled with the name of the animal. The cats are all labeled cat. The program will eventually learn that animals that look like cats are called cats. Pictures are data here. The more pictures you feed to the program, the better it will be at identifying a cat. The program does this by learning combinations of features that tend to appear together. Cats have visual features, such as their body type, long whiskers, and the way their faces look, that make them visually different from other animals. The program learns to associate their distinctive combination features with the word cat. Once it has constructed the cat model, the machine learning program tests the model by trying to identify the cats in a set of pictures it hasn't seen before. The program measures how well it did at identifying the new cats and uses the information to adjust the model, so it will do a better job of picking out cats the next time it tries. The new model is then tested, its performance is evaluated, and receives another adjustment. This iterative process continues until the program has built a model that can identify cats with a high level of accuracy. Manually labeling all the data is time-consuming and expensive. This made utilization of Internet's data fairly limited, and the Internet a vast untapped treasure. A breakthrough was needed. A learning method for computers that did not require any labeling of data or supervision and training by humans. Enter deep learning. Deep learning carries out the machine learning process using an artificial neural network. An artificial neural network, or ANN, is a computational model based on the structure and function of the biological neural network. The ANN is composed of a number of levels arranged in a hierarchy. The network learns something simple at the initial level in the hierarchy and then sends this information to the next level. The next level takes the simple information, combines it into something that is a bit more complex, and passes it on the third level. This process continues as each level in the hierarchy builds something more complex from the input it received from the previous level. Let's apply deep learning to the cat example. The initial level of a deep learning network might use differences in the light and dark areas of an image to learn where edges or lines are in a picture of a cat. The initial level passes this information about edges to the second level, which combines the edges into simple shapes like a diagonal line or a right angle. The third level combines the simple shapes into more complex objects like ovals or rectangles. The next level might combine the ovals and rectangles into rudimentary whiskers, paws, and tails. The process continues until it reaches the top level in the hierarchy, where the network has learned to identify cats. While it was learning about cats, the network also learned to identify all the other animals it saw along with the cats. So an AI can learn to recognize animals with just a few hundred images. What could it accomplish after being given petabytes of data available on the internet?
What is Deepmind? Google Deepmind is a British artificial intelligence company that was founded in September of 2010 as Deepmind Technologies. It was renamed when it was acquired by Google in 2014 for $500 million. Interestingly enough, this was just after Facebook had just finished negotiations with them in 2013. And another fun fact, Elon Musk is actually an investor in the company, just to keep an eye on them, of course. Deepmind received the Company of the Year award by the Cambridge Computer Laboratory in 2014.
Is the machine before training. So this is literally the first time the machine has ever seen this data stream, and it's controlling the green rocket here, and you can see it's losing its 3 lives immediately. So it's basically terrible at the game, as you would expect. Now after training, this is like overnight, we leave it playing the game overnight on a normal computer, so for about 8 hours. You come back in the morning and now it's superhuman level. So now the machine can play Space Invaders better than any human can. It's modeled the world, the game world so well, it knows where the Space Invaders will be ahead of time. So as the Space Invaders speed up, when you get less of them on the screen, it fires the final shot as a kind of predictive shot of where the final Space Invader will be in a few seconds' time.
But the cool thing is, after understanding how to play a few games, it will be able to transfer this knowledge and understanding across more games. So how does this all work? The AI from Deepmind uses a technique called deep reinforcement learning, which makes it very different from other AIs such as IBM's Watson or the primitive Siri or Google Now. The AIs just mentioned were only developed for a predefined purpose and only function within their scope. Deepmind claims that their system is not pre-programmed and it learns from experience using only raw pixels as data input.
So the way we start off training AlphaGo is by showing it 100,000 games that strong amateurs have played that we downloaded from the internet. And we first initially get AlphaGo to mimic the human player. But of course, ultimately, we would like AlphaGo to be stronger than human amateurs and compete with the top professionals. So the way we do that is, after we take that first version that's learnt to mimic human play, we then allow it to play itself 30 million times on our servers, and using reinforcement learning, the system learns to improve itself incrementally through it avoiding its errors and increasing and improving its win rate against older versions of itself. And after all these games, then you end up with a new version that can beat the old version, the original version, around 80, 90, 70 times.
Technically, the reinforcement that Deepmind uses is model-free, meaning that it doesn't need a structure or set of rules to learn. In a number of interviews, Dennis has talked about applications in healthcare, smartphone assistance, and robotics as possible applications for general AI. Some other applications of such AI include online customer service, computer vision, finance, general computer science, and news publishing and writing. General purpose AI actually could be huge. It can be thought of as another emerging science.
Researchers from Cornell University fed an AI 15 million photos from Instagram of people living in 44 cities around the world to learn how clothing styles vary over places and time. The researchers found around 400 common visual themes in people's clothing, such as white t-shirts and glasses, or red v-neck tops, or all black dresses. It was also learned that the popularity of the color red is dropping, that the people of Oman wear the most hats, and that the frequency of scarf use in the US is changing over the years. As long as there is enough data, supervised machine learning and deep learning can be applied anywhere and produce astonishing results. These AIs have already started surrounding our daily lives. Just look at your phone, for example. When you unlock your phone using facial recognition, navigate using your map app, receive tailored music recommendations from Spotify, or product recommendations from Amazon, check tomorrow's weather, talk to Siri or Google Assistant. It's an AI that is behind all of it. Any social media app you have on your phone uses AI to improve your user experience and target advertising to you. AI is changing entire industries by bringing immense efficiencies. Google Deepmind's AI helped the company cut its data center energy bill by 40%. Saving hundreds of millions of dollars. Self-driving cars will save millions of lives each year by avoiding fatalities caused due to negligent human driving. In healthcare, diagnostics involve a lot of scanning and imaging, and almost everything that involves scanning and imaging can now be done better by an AI. A Google AI system can now perform better than expert doctors at predicting cardiovascular problems from retinal scans. It can distinguish the retinal images of a smoker from that of a non-smoker 71% of the time, compared to approximately 50% accuracy by human experts. AI is also saving lives by early detection of heart diseases, cancers, and other chronic illnesses. AI has mastered activities that one would not expect an AI to be able to do, like creativity. An AI called Aiva is a registered composer with the Music Society. What you are listening to right now is a composition of Aiva. Another AI can write poetry. One can create puns and jokes. And another AI can even write movie scripts. It's not long before an AI produces new shows and movies. But AI's biggest achievement for now remains the AlphaGo, Google Deepminds AI, which can play Go, an abstract strategy board game which is essentially 1,000,000 trillion times more complex than chess, with an estimated number of 10 to the 174 possible board configurations, which is more than the number of atoms in the observable universe. In 2015, AlphaGo defeated Lee Sedol, an 18 times world champion. The system is now capable of defeating top 150 Go players at the same time. AI can write news, calculate calories by seeing a picture of the food, come up with its own recipes. AI can play games like Mario, Dota 2, and even poker and Jeopardy better than humans. Predict social outrage, predict crop yields, analyze the genetic code to detect genetic conditions, recognize emotions, translate speech better than professional transcribers, and talk to people on the phone without even getting recognized. Would you be able to recognize the AI if it called you?
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
The fact is, these AIs will keep getting better and better as long as there is data. Their expertise in a task is only limited by data and time. Deep learning greatly resembles how humans learn, but still the most advanced deep learning systems can only learn to do one task. This is the reason why current AI systems are classified into artificial narrow intelligence. Millions of unique AI systems, each of which can do a single task at the level of or better than humans. To truly bring a revolution at the scale of human timeline, what we need is artificial general intelligence. A single machine that excels at everything a human can do and revolutionizes not just a number of human activities, but humanity as a whole. But how do we build an AGI? Let's revisit what we learned earlier. Intelligence is the product of information processing. It means that the brain performs a set of operations on that information. The amount of information processing an information processing system, a brain, or a computer can carry out depends upon the amount of operations it can do. So for a computer to become able to emulate the brain in creating intelligence, the first thing we need is enough computational power to match the human brain. While the brain has been calculated to be capable of 10 quadrillion calculations per second, a computer affordable and accessible to an average consumer today can do around 20 trillion CPS, which is not very close to 10 quadrillion CPS of the human brain. But here's the thing about computational power. According to Moore's law, which has always been accurate, it doubles roughly every 2 years. So we will have human level computational power roughly around 2025. Great, but computational power alone wouldn't create a human level AI. Information processing also needs to follow the right set of rules, the right algorithm to create AGI. While deep learning systems might be unsupervised, it's still a human that decides what they will learn and get specialized at, and it's still a human that provides them the data. A person can learn new concepts without any direction from other people. A child can generalize the concept of cat from a single picture in a book, yet the best deep learning systems need hundreds or even thousands of examples. What we learn from doing one activity, we can apply it to another, while current AI systems fail to do so. Humans are extremely data efficient, pretty good at generalization and contextual learning, and are mostly independent. Hundreds of research groups and companies like Deepmind, OpenAI, and Vicarious are currently working to create algorithms that give AI these capabilities. When will it happen? Ray Kurzweil is one of the most accurate futurists of our time. His predictions about computers defeating humans in chess, voice command systems like Siri and Alexa, and the internet have all come true. He predicts that we will achieve human-level AI by the year 2029. Other experts point 2040 as the year of the AGI. Once researchers are able to build an AI that can grasp abstract concepts and is capable of contextual learning, it will be capable of improving itself. And finally, at some point it will reach a human-level intelligence, and we will have a computer that can do what every intelligent human can do. A computer that could produce great music, diagnose and cure diseases, play video games, and come up with scientific theories.